going to walk you through some of my research. I'll try and share with you some of the exciting things we've done. The title is The Gut Microbiome Health and Disease, You Truly Are What You Eat, kind of, because I'm going to show you one example that breaks that rule from a recent study we did in Cork. The topics I'm going to cover are: what is the microbiome and why do we need it? What happens when the microbiome goes wrong? What controls the kind of microbiome we have? Do all healthy people have the same microbiome? And what should I be doing to manage or protect my microbiome? So by the end of this evening, you should have answers to some of those questions. But before I tell you a bunch of stuff, I want you to think. And I've posed some questions here that I want you to cogitate on as I move through my slides. The first one is, they're statements rather. Bugs cause the disease, so we'd be better off having none. True or false? Bugs can cause infectious disease, but cancer is hereditary. Food can carry germs. We cook food to kill germs, so the best food is sterile. Organic food carries less bugs, which is one reason it's better for you. You get your bugs from your parents and carry them for life. Modern living is more hygienic, and so it's better all around for your health. And modern food is the safest food society has ever enjoyed. So in about 5 minutes' time, we'll be returning to those and see what you think in terms of true or false. But before that, I need you to introduce you to my little pals. And these are the components of the microbiome. And this is not a science lecture, so I don't hit you over the head with lots of technology and terminology. All I want you to realize is that you are home to a really diverse community of microorganisms, and there are 10 times more microbes in your guts than you have cells in your body. So you're essentially a genetic chimera. If a Martian came down to planet Earth and saw human beings, he would say, what clever organisms bacteria are to have invented this person who can walk around and keep them warm and feed them. And in the last 10 years or more, there has been an explosion in our ability to study the human gut microbiome, because essentially all humans, animals, and plants are colonized by microbes on their surfaces or in their internal cavities. It's only if you actually go into the deep tissue that you find areas devoid of microbes. And in this slide from a big American project, which was one of the major starters, they studied the microbiome, the nasal cavity, the oral cavity, and all these other labels, which you've been reading while I've been talking. And this is from about 10 years ago, when people began to realize that the microbiome was really important in health and disease. And here in Cork, one of the things we do well is we jump on the bandwagon. So while all of these projects were being developed around the world, as Jennifer mentioned, we started the ELDERmet project in Cork. We were lucky enough to have a Department of Agriculture, Food and Marine, or DAF as we call it, whose mandate from the government is to add value to Irish food products. And we were lucky to have some program officers who could see the possibility that your habitual diet might have an interaction with your microbiome. And the last piece of the jigsaw was we need a group of people to study. And nobody else was working on the elderly, so we launched the ELDERmet project, which, as Jennifer said, was designed to study the microbiome of 500 seniors. And we since increased that to several thousand. And I was fortunate enough to be in the right place at the right time in the APC to be able to lead and coordinate the ELDERmet project. So now that you've become familiar with the idea that we're all colonized by bugs, I need you to look at this in terms of the time frame of a human lifespan. Because when a baby is born, they're essentially devoid of any microbes. And what happens is they're colonized in an almost haphazard fashion with a few caveats. And by the time they're a toddler, age 2, they have a microbiome which is pretty much similar to an adult microbiome. We used to think it had thousands of species, but actually it only has about 200 species and maybe a couple of thousand strains. And that microbiome is stable throughout adulthood unless you have a disease, more of that and then on. And then at the other extreme of life, the elderly, it seems that the microbiome seems to enter another phase of total flux. So ELDERmet aimed to figure out if any of these microbiome changes in older people had an influence on aging-related health loss. And while all this was going on, there was, as I said, an explosion of interest in the microbiome. And these are a series of observations which I won't go through for reasons of time, but I just want to convey the fact that the microbiome has co-evolved with humans over tens of thousands of years. Because it has co-evolved as we changed our lifestyles, our diets, our social patterns, moved from breastfeeding to bottle feeding, the microbiome had to change too. And it does some amazing stuff. So for example, somewhere on here says that the skin microbiota influences mosquito attraction. If there are 10 people in the room and one mosquito, the mosquito will nail me. There must be something wrong with my skin microbiome. Gut microbes produce neurotransmitters and influence stress, anxiety, and mood. This is an area of active research in the APC, of which I'm a member. And Professor John Crine studies the effect of the microbiome on behavior, cognition, depression, and there's even some exploratory research on neurodegenerative diseases. So the microbiome has a range of important functions, some of which I'll exemplify in the following slides. This is a fascinating photograph of a woman about to give birth somewhere in the francophone world, depuis la Bible on enfantait dans la douleur. And you can see that if you study these kids, they're arranged in a stairs. I think there's a fourth kid in behind the midwife here, and they're looking on with a mixture of horror and fascination. And the woman is giving birth at home. There's an old tin here with the dirty rag in it, and it doesn't look too flash. It's certainly not the clinical standards we'd expect in a maternity ward in 2021. But that's how kids were born for the last 50, 100,000 years until we came along and started to do this. This is a C-section birth in an operation theater. And what we know is that babies delivered by C-section have a microbiome which is as similar to the physical environment as it is to their mom's birth canal. Because normally when a baby is delivered by standard vaginal delivery, it's deliberately inoculated with vaginal bacteria, including bifidobacteria and lactobacilli. And interacting with breast milk, it gives the baby a head start and gets the gut microbiota community established. Now, I'm not saying C-sections are bad. I know that C-sections are life-saving procedures, and under lots of circumstances, they're absolutely required. But in some countries, C-sections are elective and constitute up to 70% of live births. So that's an experiment in human gynecology and microbiology on a global scale, and we don't really know what the outcome of that is going to be. Let me give you some tantalizing hints about what the outcome might be. This is the so-called hygiene hypothesis, and this is from a nice review by Jean-François Bach. And many authors have contributed to the formulation of this hypothesis, but basically it goes as follows. From World War II onwards, we became really good with medicines, antibiotics, and vaccines, and we started to see dramatic declines in the prevalence and incidence of some major diseases like rheumatic fever, measles, mumps, and TB. Ironically, TB is on the way back up. Over the exact same time frame, we saw dramatic increases in a group of diseases which I would loosely combine as immune dysregulation diseases. I have to be careful with my wording because in some of these diseases, they appear to be autoimmune diseases, but in others, they're not. In others, like Crohn's disease, it's more a fact that the innate immune system is in overdrive and you're getting this really bad inflammation. So the original hygiene hypothesis stated that the eradication of organisms that we used to expose to all the time meant that the immune system was no longer being programmed, and as a consequence, we saw a dramatic increase in these immune dysregulation genes. The hygiene hypothesis has been refined in the last 10 years to form the old friends hypothesis, which is similar. And it basically states that it's not just the elimination of pathogens, which has been important for this phenomenon, but also the elimination of commensal bacteria, the so-called good bacteria. I hate that term, but I'll use it in a general audience like this. The bifidobacteria, the lactobacilli, the faecolobacteria, the roseburia, the eubacteria, all the other bacteria that rejoice in unpronounceable Latin names. They are being eliminated, and one of the functions of the gut microbiota is to help program innate immunity. So the answer to one of the questions is we've co-evolved for them, and they provide necessary functioning such as program your immune system to help you distinguish between self and non-self. Okay, so returning to those questions, you've had time to think about them if you can remember them. Bugs cause disease, so we'd be better off not having them. I hope I've answered that already. Some of these so-called commensal bacteria or normal resident bacteria are absolutely necessary. We're told from a young age, you've gone to the loo, wash your hands, all bugs are bad. That's not true. You have a thriving community of bacteria in your guts, and some of them you have to keep. Bugs can cause diseases. Well, that's true, but cancer is hereditary. I'm getting off topic here. Some cancer is hereditary. A minority of cancer runs in families. Most cancer is sporadic because you either do stupid things like smoke or lie in sunbeds, or else you're just unlucky and you get exposed to mutagens in the environment and you don't know. Food can carry germs. Yes, it can. Unpasteurized yogurt carries germs. Fermented sauerkraut carries germs. But unless we're talking about Listeria and Salmonella and food pathogens, germs per se in food is not a bad thing as long as you know what the germs are. We cook food to kill germs, so the best food is sterile. That's not true either. I've seen some of the healthiest people with the best gut microbiomes in people who eat fermented food almost exclusively. The highest diversity microbiome I ever saw was from a young producer's assistant from Channel 4 who came over to see me. They were doing a documentary and we profiled her microbiome, and she had more species than people in South America, the native Amerindians in the Amazon, who have a really complex microbiota. She only ate fermented foods. So sterile food is not necessarily a good thing unless you know you have to kill things like Campylobacter in chickens. Organic food carries less bugs, which is one reason it's better for you. It typically doesn't carry less bugs. In fact, in some circumstances, depending on the supply chain, it might actually carry more bugs. If it's better for you, it's because it's apparently carries less pesticides and herbicides. But pesticides and herbicides are very tightly controlled in the EU because, as we know, the EU are very good at regulating things. That's why our UK cousins don't like them. So that's not true. And organic foods may or may not carry less bugs depending on how they're handled. And as to whether or not they're better for you, well, the jury's out on that. I think nutritionally, most organic foods are very similar to their conventional counterparts. I'm getting a bit of feedback, so if you have a live mic, you might want to mute it because I can certainly hear some crackling there. You get your bugs from your parents and carry them for life. The first part is true. You get some bugs from your mom, but you don't carry them for life because for lots of reasons, you have the ability to mess up your microbiome, and there are consequences for that. Modern living is more hygienic. That's true. So better all around for health. Not true. Excessive sanitization, the hygiene hypothesis, and I'll show you some other examples, is not necessarily good for you. You have to have moderation in all things. Modern food is the safest food society has ever enjoyed. That is unequivocally true. We've never had a safer, pathogen-free food chain than we currently enjoy. Okay, what happens when the microbiome goes wrong? Well, there are lots of diseases with proposed microbiome linkages, and I get emails every day. I got an email this evening from a gentleman whose nephew has IBD. And IBD, or inflammatory bowel disease, is one of the better examples. This is what your colon should look like. But if you have ulcerative colitis or Crohn's disease, you get ulceration. It can bleed. If it gets really bad, you might have to have surgery and have a piece of your bowel cut out. And you may know some celebrities that have IBD. And it appears that there are distinct microbiome changes associated with IBD. A related disease, which is less dramatic, but is more common, is irritable bowel syndrome. Probably affects 5 to 10% of the Irish population. It means that they have alternating bouts of constipation and diarrhea. They get distended bowel. It messes up their life. 2-to-1 predominance of young women, particularly in the most productive phase of their career. And it's a difficult disease to manage. And it's caused in part because you get a bloom of bacteria which ferment food and cause the luminal pH, the pH of the center of your gut, to be acidic. And that triggers your nerves and it messes up with your brain control of your bowel. That's my hypothesis of irritable bowel syndrome. One that I want to come back to is heart disease. You might think of this, atherosclerosis. It's where you're getting clogged arteries. This is what your normal artery looks like. It's an effective pipe. And under some conditions, it gets blocked by this, what we'll call gunk, a non-scientific word. It's a plug of dead macrophages, bits of fat, calcium, and cellular debris. And all I want you to do is remember that there's a key microbial metabolite, TMAO. Actually, it's not truly microbial, it's a co-metabolite, but bugs are involved in making TMAO, which drive this process. So that's why something outside of the gut can cause something as important as blocked arteries and stroke. And the last one, which I mentioned, is colon cancer, which is something we work on very intensively in Cork. Bacteria appear to be involved in the final stages of colon cancer after you acquire mutations. Now, colon cancer is a complex disease. You have to get all these mutations first, but it appears that certain bacteria might, if you will, push you over the edge of the cliff. You get to a certain stage, you get colonized, believe it or not, by oral bacteria in your colon, and they probably push you past the last mutation. And we've actually developed diagnostics based on combined oral and gut microbiome to detect early stage colon cancer through little mushroom-like projections called polyps. Okay, so one message is that the microbiome is associated with diseases, but you'll see articles claiming the microbiome is involved in everything under the sun. And I would urge you to approach that with caution because A, it's not true. B, there's evidence for very few of those. And even the ones that I tell you I believe in, the evidence is still a work in progress. It's an exciting area, but we're still in early days of an exciting field. Okay, so you have a microbiome and you probably figure, well, maybe I should figure out what kind of microbiome I have and figure out how to control it. So I'll try and tell you how we got to the point where we think we know what controls your microbiome. It goes back to the ELDERmet study. Now these graphs, you'll see quite a few of them, so I'm going to explain them. Each of these dots is a person, or more correctly, their microbiome. So these two people down here, pointer options, hopefully that helps. These two people down here have a very similar microbiome, but they have a microbiome which is very far away from the person over here. It's as simple as that. And then the color labels refer to people, older people living in the community, in other words, living at home, buying their own food and cooking their own meals. And then the other major group in red are people living in long-term residential care. They're from several hospitals around Cork City, and they're living in long-term residential care. There are a few other small groups we can ignore, and then there's some young controls. These are scientists around UCC in purple. And basically what you see is that all of the elderly people, all over age 65, living in the community are down here, and all the long stay people are living up here. So it appears that where you live in Cork determines the kind of microbiome you have, or more correctly, where you live in society determines the kind of microbiome you have, and we weren't expecting that. And you'll notice that the young controls cluster with the microbiome of the community dwelling subjects. And using a fancy stats method, which I won't bore you with, it appears that the habitual diet, which we call the food frequency questionnaire, we asked these people what they eat every day, and that dietary data co-segregates or has the exact same pattern as does the microbiome. So in other words, what seems to be the case is that if you live in the community, you have a healthy diet. If you have to be admitted into a long-term care facility, your diet changes overnight because you have to eat the food that you're given. And within 6 months, your microbiome will move from this quadrant, which is a high diversity, good microbiome, to a low diversity microbiome. highly suggestive that the diet is driving it. And we also know that these people are sicker. And these microbes correlate with health, and these microbes correlate with frailty and sickness. The obvious weakness in this approach was that we had chosen two polarized groups of older people: healthy people recently retired living in the community, and people living in Cork long-term care facilities who by and large were 20 or 30 years older and had a lot greater burden of disease. So like every good scientist, we need to figure out a way getting around that. So what we did is we went back to community dwellers and we recruited a much larger number of them. So we had close to 250 at that stage. And we broke them down into three groups depending on what they ate. The most healthy group had a healthy diet, and you don't have to read the color scheme. Basically, everything green is good. It's fruit, veg, cereal, fibers, and all that jazz. And everything in red and orange is bad because it means high-fat dairy, lots of desserts, lots of red meat. And you can see that the green proportion has dramatically dropped down to about a quarter of the pie. But all of these people are living around Cork City. You see them every day. These are people who just, I won't say voluntarily, because sometimes this happens where you've got an elderly couple and either the wife dies and the man can't cook, or the husband dies and the wife is brokenhearted and couldn't be bothered cooking for herself anymore. So for lots of valid, completely understandable reasons, people living in the community who are apparently quite healthy choose to eat what we call a long stay like diet. Now you're probably wondering, what does a long stay like diet look like? And it looks like a traditional Sunday dinner in most traditional Irish households. It'll be cremated meat, some soggy potatoes, and a big bowl of trifle at the end of it. And some of these people will eat the trifle and leave most of the good stuff behind. So why am I telling you this? If you look at the microbiota, and it's got all these weird names, it appears that the people in the community with a long stay like microbiota have a very different microbiome. A long stay like diet, sorry, I misspoke. They've got a long stay like diet, and they have a microbiome like people who've been living in long-term residential care for 2 years. You can voluntarily or unwittingly eat yourself into a bad microbiome. So this is the group I want you to focus on, the long stay like microbiota group living around the corner from you in your flat when you used to live in Cork in the good old days. Now, the people in the community with a diet like long-term care residents have inferior health. There's 4 different graphs here. These are microbiome groups, which I'm going to skip over. And I just wanted to draw your attention. This is the functional independence measure. For older people in society, what you really want to be able is to allow them to live by themselves. What these people want is to live at home till the day they die. And we can put a number on that ability called the functional independence measure. And most of these people with the good microbiome, the good diet, are maxed out. But the people who have the long stay like diet and microbiome have lower values, clinically importantly lower values for the functional independence measure. They also have lower values for a test for their cognitive function, the so-called mini mental state exam. And that's clinically significant. And they have higher levels of a blood marker for inflammation called IL-6, meaning that their innate immune system is turned on all the time. The last test was for loss of muscle, but we didn't see that, at least not over this time scale. So if I could summarize that graphically in a slide prepared by my colleague Fergus Shannon, what seems to be happening is that these people, as they age, their dietary diversity declines for various reasons. Their microbiota diversity declines. Their inflammation increases. These are those blood markers, and their frailty increases. So one thing that we could do to help delay the onset of aging-related health loss in older people is to improve their diet. So diet is one obvious factor which messes up your microbiome. Now, other things are antibiotics. And I always then get the question, should I stop taking antibiotics? Absolutely not. If your doctor says take antibiotics, grab them with both hands, because it probably means you've got sinusitis, or you've got a tick bite, Lyme disease, or you could have community-acquired pneumonia, God knows. In some circumstances, antibiotics are absolutely required, and you should take them. it turns out that other common medications also impact your microbiome. So for example, metformin, which is one of the most common medications used to treat type 2 diabetes, interacts with your microbiome. In fact, we think that metformin works really well, and it might work by changing the microbiome. And other things which, again, you can't typically avoid, like certain illnesses, certain surgeries, treatment with immunosuppressors. If you have cancer, you have to get chemo or an organ transplant, which would be more dramatic, anorexia and radiation. All of these external factors impact on your microbiome. Diet is really interesting, and other people have published studies. Again, you just need to look at the colors. We've got herbivores up here, we've got omnivores in blue, and you've got carnivores in red down the bottom. There's not that many carnivores. And again, the position of these animals in this plot is determined by their microbiome. So herbivores have a very different microbiome to omnivores, who sit halfway between herbivores and carnivores, because omnivores are like most of us, and we eat a bit of this and a bit of that. We were interested in this, and we started to collaborate with a group in Naples who became good friends of ours, because they had a nice cohort containing omnivore humans. Now we're talking humans, vegans and vegetarians. And these plots are a bit complex, but basically each of these vertical lines is a person. So you can see this person here is eating an awful lot of, these are the food ingredients. So this heat map means that this person is eating an awful lot of these foods. In fact, the omnivores in general are eating loads of these foods, which are the meats, and very little of these foods down the bottom, which are the plant-based food types. The vegans are the exact opposite, because they're avoiding all these meats. Somebody's fallen off the wagon here a few times. And the vegetarians are obviously less strict. They have a bit of meat, but mainly plants. But the important thing is that in terms of the microbiome, they separate out. They have different microbiomes. This tree is based on the separation of the microbiome. So if you're a vegan or vegetarian, you have a different microbiome to me. Congratulations. Well, who cares? Does it make any difference to your health? A couple of minutes ago, I told you about this metabolite TMAO, which is involved in coronary artery disease. Omnivores have high levels of TMAO because one of the sources of that metabolite is red meat, carnitine. Vegans and vegetarians have very low levels. So you could say, so far in the story, if I want to avoid the risk of coronary artery disease, I should become a vegan or vegetarian. But it's way cooler than that, because if you strip off these labels and look at the level of adherence to a Mediterranean diet, the Med diet compliance. So I'm an omnivore, but I probably eat less meat than other people. So I would say I have a relatively high level of compliance to a Mediterranean diet. So if I was living in Naples and I was in the study, I'd be down here. If you were a real old-fashioned carnivore, omnivore, you would have a high level of this metabolite, which is bad for coronary heart disease. So what that means is that as an omnivore, you can partly mitigate or you reduce your risk for coronary artery disease by having some level of compliance to a Mediterranean diet. And I've already showed you that this affects your microbiome. So I became very interested in the Mediterranean diet because the Mediterranean diet is a cultural heritage recognized by the United Nations, and it's not Italian food. I mean, if I go to Naples quite often now, well, I used to before all this stuff happened, and you see kids playing soccer in the piazzas, and they were obviously had a high BMI. They were heavier than they should be, because nowadays Italian kids, all they eat is pasta and Nutella. A real Mediterranean diet is not Italian food. It's, well, I'll show you in a couple of minutes' time what it is. So to make a long story short, we ran an EU project which was based in Bologna by a friend of mine, Claudia Franceschi. And we went to 5 European cities in these countries. England was still in the EU at that stage. And we recruited 250 people in each of those subjects. And we profiled their microbiome, which is pretty risk-free. And then we took two groups of 570, and one of them we put on a Mediterranean diet for 1 whole year, and the losers had to eat their own diet for 1 year. But this was a really expensive project, and only the European Union could have paid for it. But the good thing is that it worked. So I've got a couple of descriptive slides. I'll skip over that because it's not that interesting. This is what the med diet looks like. The project was called New Age, and you can see that people on the New Age med diet had more whole grains, way more than the controls, more vegetables, more legumes, beans, more low-fat dairy, low-fat cheese, more fish, nuts, olive oil. Yeah, they're big into olive oil. And the good news is you're also allowed to drink red wine because it contains resveratrol, and that's good for you too. And we had a slew of papers. I wasn't not involved in the nutritional side. I just stand back and applaud these people. I was involved in the microbiome side of things. And the paper got a lot of traction because it turns out that if you had a high level of Mediterranean diet consumption, you had a change in your microbiome, and you promoted the growth of so-called diet-positive taxa. And high levels of these was associated with better memory, better cognition, and grip strength. There's a nice little device that you can squeeze, a bit like an exercise yoke in a gym, and you can measure people's grip strengths. So going on the med diet for 1 year increased the abundance of a group of microbes, which correlate with improvements in these scores. We also saw reduced inflammation, lower frailty or less onset of frailty, lower appetite, which is actually a good thing, and their gait was faster. One of the tests, believe it or not, for older people is the so-called get up and go test. Get out of an armchair and walk 10 yards across the room. And people on the med diet were able to do that much faster. And it's probably the most popular paper I've ever published. It even got onto CNN, which was kind of cool. So the microbiome is important for human health. What kind of human is this? This is Apis mellifera, or the European or Western honeybee. And it is a total diversion. I just want to show you that the principles of microbiome research can easily be applied to other animals. So I'm a hobby beekeeper, and a couple of years ago, I went to an apiary down in a peninsula in West Cork. The beekeeper wants to remain anonymous, so I'll just say it's somewhere in a remote peninsula in West Cork. This is a map of the guy's house, and in his apiary, dotted around the map, he had thriving hives in green and non-thriving hives in red, right side by side. You can see that there's mixtures of thriving hives and non-thriving hives, and we can define what thriving means in terms of how much honey they make and how many bees they have. And when we looked in the gut and the whole body, the non-thriving hives had much lower microbiome diversity than the thriving hives. And when we drilled into the microbiome, we saw that the bugs that were missing in the non-thriving hives were necessary for turning the summer nectar flow into energy for the bees. So one of the things we're playing with, this kind of hobby project, is to fix the microbiome of non-thriving bees, because as you may know, these bees are challenged by colony collapse disorders, and it's not a good time to be a honeybee. And we've continued that project with a nice small grant from a UK foundation, the Eva Crane Trust. In 2019, I was traveling all around Ireland surveying bees all over the place. 3 different time points, so we'll be reporting that back on that pretty soon. The last segment, drawing to a close, important question: do all healthy people have the same microbiome? The short answer is no. If you were on campus in Boole 4 and I took a sample from you, and I won't tell you how I'd do that, and I went back to the lab and analyzed it, you'd all be ostensibly healthy, but you'd have quite large variations in your microbiome. A couple of years ago, a colleague of mine persuaded me that we should do something about traveller health. Now, Irish travellers are a very interesting group in society. They're formally recognised as an ethnic minority. This is going back to 2017, when there was an apology from the Taoiseach. They constitute 1% of the total population. There are around 1,200 travellers in Cork, and they suffer from discrimination, they suffer from racism, they suffer from marginalisation, they suffer from deprivation and lack of access to healthcare and lots of other community supports. And at a time like this in human civilization, they're really badly challenged with COVID-19. And to make matters worse, in 2002, the government passed a bylaw which effectively ended their nomadic lifestyle overnight. So the pictures certainly people of my age have of travelers when we grew up traveling around is now essentially impossible because they get fined, they can end up in court. There was a really nice issue of National Geographic a couple of years ago by a journalist who went and lived with the travelers for 4 years. And there are a lot of relevant observations on traveler lifestyle which interest us as microbiologists, because although they have issues in terms of health problems, they actually have a lower incidence. Remember those diseases I told you about immune dysregulation? Those diseases are less common in Irish travelers than they are in the so-called settled community. So I have a friend and colleague called Fergus Shannon, who is a very stubborn guy, and he was nagging me for years that we should partner with the travelers and study their microbiome. And I said, Fergus, we're probably not going to find anything interesting. But fortunately, he wouldn't let me off. And we did the study. We recruited 118 adult travelers. Some of the stats are interesting. The sibling size, so they had approximately 10 brothers and sisters combined, plus or minus 4. 95% of them had nomadic parents. 93% of them had been nomadic up to the year 2002, in other words, during their childhood. But now 73% lived them in a house of sorts, and 27% lived in a halting site. And you know what halting sites are. And the lab team involved here was Dr. Trini Ghosh is an amazing postdoc in my lab. He's head of my bioinformatics group. And Dr. David Cohan was a medical registrar who was studying under Fergus's guidance. And also involved was Professor Mick Malloy, who's a rheumatologist. This was all based in Cork. So what did we find? Now, I've introduced these plots to you so you know about these. Look at the red. These are young Irish people and elderly Irish people living in the community. And then in green, we've got the long stay Irish folks. Off in left field are the travelers. Okay, they're spread out a good bit, but the Irish travelers seem to have a microbiome very different to the settled Irish community, be they young or old. So what we did next truly blew me away. We went to a global scale, and I know this is kind of squashed. The top black circle are so-called industrialized populations, and they include the elderly Irish, we've got Americans, Chinese, French, blah, 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 Austrians. Down at the bottom, we have non-industrialized populations from Tanzania, the Hadza hunter-gatherers, Peruvian Indians, Madagascar and Fiji, and then you've got Mongolia. And the Irish travelers are clustering with non-industrialized populations from the far side of the world. I would not have predicted that in a million years. If I zoom in on that and focus on the so-called industrialized subjects, so this is probably you and me and most of us in this audience. The Irish travelers break into three groups down here. The Mongolian subjects are up here, and then the non-industrialized, with exceptions of the Mongolians, up here. So we can see the travelers are very different, and they include 3 different degrees of relatedness to either the non-industrialized and the industrialized. And long story short, the positions of these 3 groups depend on their degree of travelerhood and how long it is since they were forced out of a nomadic lifestyle. So these would be the oldest people, and these would be the youngest people who've had a traveler lifestyle for a relatively short time. Interestingly, the distinctive traveler microbiome is not related to diet. It's the one example in my talk which is not. It's dependent on housing, family size, and proximity to animals. If you talk to travelers, the most important thing they'll want you to learn is that to help travelers, you should not try and settle them and make them like you and me. They want to retain their ancestral lifestyle. They want to have large multi-generational families, and they want to have access to their animals. And it now transpires that they maintain an ancestral microbiome, well, at least up to the year 2002, when they were forced to settle. Now, vertical transmission of microbes is important, and what stops that is C-section antibiotics, and breastfeeding is good because it reinforces natural gut bacteria. The other phenomenon is horizontal dispersal, which happens easily in travelers in the kinds of communities they occupy. It happens easily in other non-industrialized society because they live in large groups and they prepare food together. And there's probably also an element of proximity to animals, because other studies have shown that the more you expose yourselves to animals, the more diverse your microbiome and the less the incidence of immune dysregulation disease. So to summarize this part of the talk, it issues a challenge to the concept of the normal microbiome in a multicultural society, because travelers living close to us have a very different microbiome, a microbiome which is best for them. It stresses the importance of non-dietary factors and the changes of microbes with modernization and the public health implications when an ethnic minority is pressured to change lifestyle. This does not apply exclusively to travelers. If you consider migrants, refugees, people who come to Ireland from Syria, people from war-torn countries, people who embark across the Mediterranean in rubber dinghies and end up settling in Europe, undergo rapid changes in their microbiome. In the case of the traveler, it appears that they have a microbiome which probably has a role in protecting them from immune dysregulation diseases. Then we force them into houses and halting sites, and they get a Western style microbiome, which they're not equipped to deal with. And we also make it harder for them to engage with the health services, which is probably they have these lifestyle diseases. So what we've done here is to use 21st century science as an historic record of traveler ethnicity. So to wrap it up, and I want to leave some time for questions, what should I be doing to protect my microbiome? The first thing is you should feed your bugs, not yourself. Now, I know that's kind of stupid because you need to eat nutrition, you need to survive. But if you go back to the food pyramids, and this is from Safe Food Ireland, and you're familiar with that, you should eat the things at the top of the pyramid in the lowest quantities. All of this makes complete sense in terms of providing ingredients that gut microbes can turn into beneficial substances. All of this perfectly resonates with what I told you about our observations of eldermet, about high quantities of sugar, fat, salt, and high glycemic index. Dietary ingredients correlate with a poor microbiome, whereas intake of vegetables, salads, and fruits correlate with a very good microbiome. So bear in mind that nutrition is not as simple as what you eat going straight into your circulation. Your gut microbiomes have to convert it, in some cases, into metabolites that you can use. You're not a passive victim in all of this. You can control your own ecosystem. Other people in the APC have shown that the level of activity and exercise has an impact on your microbiome. And you obviously know that the more active you are, the faster your gut intestinal transit. This inspirational gentleman is 100 years of age. Well, that was 9 years ago. I hope he's still with us. I hope he's been vaccinated by now if he is. Anyway, the point is that by adopting a healthy lifestyle, and it's obviously much more complex than running around preparing for marathons, you can control the other facets which impact on your overall health. And a message to everybody, especially parents, is avoid infections, but don't over sanitize. This is taken from a Canadian website, and the title of the article is "It's Safe for Children to Play in the Mud." The name of the organization, to give them credit, is Kids Do Gardening, and their whole ethos is to promote kids playing in the mud. Because if you over sanitize, and if you've got bactericidal wipes and spray bottles all around your house, and if when a visitor comes to your house to get an overwhelming smell of J pine, it's probably not a normal ecosystem for either for you or your microbes or the members of your family. I've had fun giving this talk, and I've had fun generating the data. And most of that is due to the fantastic people I interact with in work in the School of Microbiology and APC Microbiome Ireland. So that's a centre with 150 core staff and up to 400 ancillary staff. And we get to play with this every day. We recruit lots of grad students directly from UCC and professional scientists from around the world. And maybe someday we'll see some of you in the APC or in the School of Microbiology if you're considering your major options. I'd like to particularly thank my friend and colleague Fergus Shannon and all the people in my lab, past and present. I've picked a very short list here, which is non-representative, but they've all been a great help. And lastly, we're lucky in Ireland to have had consistent science funding due to the prescience and anticipation of our government. And I've given you some good examples of that. And the main agencies are Department of Agriculture, Food and Marine, Science Foundation Ireland, the Health Research Board. So on that note, I'll conclude. I heard lots of crackling. I hope you're all still with me, and I'll be happy to take any questions.
Thank you, Paul, very, very much for that seminar. On behalf of everyone here, I'm sure that everyone agrees when I say that that was such a fascinating insight into our gut and how our microbiome affects our health and how it's affected by our diet and its role in the world around us, basically. Thank you so very much. We've all learned so much from that seminar. So we're going to move along now to the Q&A session. So this is just a reminder for anyone, please send in your questions into the chat and we can get to them. So just to start off with, I guess, quite a broad question, just back to the beginning, I guess. Where would you say your interest in microbiology stems from? So what sparked your interest first day?
I would say it's because we had an inspirational professor of microbiology in Trinity back in the 80s. And he worked on a toxin called scalded skin syndrome. And in a first year lecture, he was trying to figure out how this toxin worked, and he injected it into his own arm. And his wife, naturally enough, went completely ballistic. Nowadays, if you did this, you'd go straight to jail. It's such a violation of ethics. But he survived, and the toxin did not damage his skin because it only works on babies. So it was an inspirational teacher, and that's often the case, which inspired me that microbiology was where I wanted to go, because like many of you, I went into a general science intake and I could have chosen lots of different directions. But I chose microbiology, and I'm lucky because I've never worked a day in my life. Just do my hobby.
And that's a great thing to have, you know, to be able to, you know, work on your passion as a job. So we've had some questions as well that were sent in advance, very interesting and insightful questions. So the first one is, how much time does a healthy diet or supplementation of prebiotics take to shape the gut bacteria?
Yeah, that's a great question, Jennifer. So the short answer is at least 6 months, depending on how much you take. We have a paper which is published, which I didn't talk about today, where we gave elderly people and young controls 20 grams of fiber a day. Now, that probably doesn't sound like a lot. It's about half a cupful. And it was actually a mixture of 5 different fibers. And we saw a slow change in the microbiome, but only in the outer shell. We weren't able to program the deep layers of the microbiome. That may have been because of the kinds of prebiotics we chose. For those of you in the audience who don't know what a prebiotic is, it's a dietary ingredient, typically a carbohydrate, typically a fiber, which you cannot digest, but your gut bacteria can. And examples would be gos, phos, or inulin, chicory root, the kinds of things which people take when they're constipated because they give a real kickstart to the gut. So the short answer is at least 6 months, and you have to eat a lot. And if you're not used to taking prebiotics, you may have some initial discomfort. A lot of people find them very beneficial, and certainly for constipation, they certainly are. But from a microbiome perspective, you need to take them for a long time.
Thank you for that. Is there anything specific you would recommend for pregnant women, either to add or remove from the diet? And what is the impact of the microbiome on fertility?
Well, for the first part, I'm going to plead the Fifth Amendment, which is I'm not a qualified physician. I'm not authorized to give medical advice to anybody, particularly pregnant women. They should talk to their doctors. I suspect the doctor would tell them to eat a healthy, balanced diet, but there are particular issues in pregnancy, as you know, in terms of making sure they get enough folate. So pregnant women will be connected to the health system, and they should talk to their doctor or a qualified nutritionist, not a quack like me. I have never heard anything about the effect of the microbiome on fertility. I assume that fertility, everything else being equal, will be higher if you have a general overall health, but I know of no published studies definitively linking microbiome alterations to human fertility.
Thank you for that. It's definitely, I guess, an under-researched area there.
I think so, yeah.
Yeah, definitely. Someone said there seems to be a link between the gut microbiome and obesity, as well as metabolic disorders. Would you say that the evidence in your research so far suggests that gut microbiome transplantation could actually be a possibility in fighting these
Right. That's an
problems?
amazingly good question. I know that sounds patronizing, condescending. It's not. I'll tell you why. We were the first people in Ireland to start fecal transplants. And if you don't know what that means, it literally is a poo transplant. Somebody has a condition called recurrent C. diff infection, or C. diff, C. difficile, and they're almost dying. And if you give them a poo transplant from healthy donor, typically in the back door with a colonoscope, and you trickle it back out and you seed it with a healthy poo sample, they will recover in 24 hours. The first one we ever did was a woman who was in hospital for several weeks. She had 3 kids. She was severely ill. She had 20 bowel movements per day. We gave her 2 FMTs and she went home within 2 days and never turned back. Now, the specific question is gut microbiome and obesity and metabolic disorders. This includes type 2 diabetes. We've just completed a study with a group in Amsterdam, which is the world leader in FMT for diabetes. They published an initial paper, which was very exciting, and it looked like an FMT cured diabetes, at least peripheral insulin resistance. The second study they published was less optimistic. So they said to me, let's combine it with a Mediterranean diet. So what we did was we took diabetics, we gave them a Mediterranean diet for 2 weeks, and then we gave a fecal transplant. The amazing thing was that although they all improved, the net improvement was during the first 2 weeks based on the med diet. And when they got the fecal transplant, they didn't improve at all. That observation resonates with the increasingly pessimistic outlook for FMT, for metabolic disease, but it does say that a med diet in its own right does seem to have some beneficial effects for people with type 2 diabetes. So that study has just been submitted for publication. And to give them credit, the leader in the group in Amsterdam is Max Newdorp, who's a recognized world leader in FMT for metabolic disease.
Yeah, that's very interesting. And just kind of a similar question that links in, would you say that, FMT could be used to treat serious anaphylactic allergies?
No, sorry. I have to be really honest about FMT. I get questions all the time. I get really sad emails. FMT works for recurrent C. diff pretty well, IBD a little bit, but not enough to sell the farm. And for most other things, no. So don't consider an FMT. Don't go off piste and get one yourself. And don't, for God's sake, do it at home, because it's not a risk-free procedure. It's a witch's brew of unknown bugs if you do it at home. It's highly dangerous.
Yeah, of course. Thank you for that. We have a question in the chat from Ian. He says, about 70% of your immune system is in the gut. Is this interaction a viable mechanism for future medicines to treat inflammatory diseases?
Up to a point, Ian. I would say my buddy Fergus distinguishes between broken biome and broken host. So what that means is that in some cases, because of bad behavior or bad luck, your microbiome goes off the rails. And I think in aging, that's a case in point, because people eat terrible food for 10 years, but we hope to be able to bring them back. But IBD is a condition where first of all, you've got known genetic risk factors for IBD. There's about 20 good candidate genes, which increase your risk for IBD. And once IBD is triggered, it's very hard to fix. Even though people with IBD have an altered microbiome, I'm not convinced that it can be fixed by fixing the microbiome. So a good example where inflammatory diseases are cancer therapy. So one of my pet projects at the moment is treating patients who have malignant melanoma with a new class of drugs called checkpoint inhibitors. I won't make this long-winded. And basically, whether or not a patient responds to checkpoint inhibitors depends on the gut microbiome. Tragically, only about 30% of people respond to checkpoint inhibitors, and the non-responders have a low diversity microbiome. And the reason I'm linking this to Ian's question is that in the people who are non-responsive, it appears that their inflammatory status is pretty much permanently turned off. And we hope to be able to rescue those people by dialing back their inflammatory response, because that's what actually is clearing the tumors in people with malignant melanoma all their bodies. So it's a partially positive answer, Ian. In some cases, yes, and others, no.
Yeah, that's very interesting data there, like a unique insight into that kind of area. Again, a lot of more research to go in there as well. So quite an exciting field. Um, would you say that an altered gut microbiota could become such that it results in doping practices in elite athletes?
I read that question a couple of times, Jennifer, and I'm not sure that I understand what it means. So maybe you can explain to me. So I'm going along minding my own business. My gut microbiome changes, and then I decide a better. You mean, does it mean that people report false positives in doping tests?
I'd say what the question means would, if someone has a healthier microbiome, would that have some advantage in sports compared to those with a less healthy microbiome in any way?
Okay. Yes, the short answer to your question is yes. And we know that because my colleague Paul Cotter and Fergus Shannon has studied the Irish rugby team in camp about 5 years ago. This is published. And they were just coming back off their summer holidays. So their diet was kind of crap at the beginning. But as the management got them under control, they had massive amounts of calories. But it was clear that they were harboring gut microbes, which helped them to convert those calories into beneficial metabolites. I don't think it has any connection to doping practices at all, because doping detection is based on very specific metabolites derived from chemicals, which have nothing to do with gut microbes. So there may be some crossed wires there.
Yeah, it'll be definitely interesting to see if it actually, becomes one of those illegal doping stimulants in the future, having a better and healthier microbiome.
No, I don't think so. I don't think so.
We have another question in the chat. It relates to the Mediterranean diet from research. So over 1,100 people took part in one study and 570 people had the Mediterranean and others didn't.
Yeah.
Very expensive, so must have limited the sample size, but was there not an issue with the sample size? Do you ever have to defend your paper against a small sample size?
For a study like that, a lot of microbiome studies are 100 people. So that's one of the largest. There are other studies which have just tracked what people have by accident. And there was actually a med diet study came out last week in Nature Medicine, and it was from doctors and nurses in the Harvard medical system. And what they did was they just asked them what they ate, and they put them on a spectrum of low to high med diet adherence, and came out with broadly similar results to us, except what we did is we put people in the UK, I'm sorry Ireland wasn't involved, the UK and Holland, and they have a pretty stodgy diet like us, onto a med diet. And it was expensive. Every Sunday night, a little van appeared outside their apartment with a box of free food. So the sample size, I know what they mean. And like my statistician, whenever I say, how many people do you want? They say, give me more, double it, multiply it by 10. I'd love to have tens of thousands, but that study cost like €7 million. And a huge chunk of that went on the food part alone. So, no, I was happy with the sample size, and the beneficial effect had been reported based on the dietary intervention alone, had already been published. We were the ones who just linked it to the changes in the microbiome.
Yeah, and even when you take, as you said, when you take into account the cost and the resources and the time and work that goes in, it is quite a large sample to work with. So we have another question. Would long stay like elderly patients with the associated microbiome suffer more from COVID-19 as they have elevated levels of IL-6, which is associated with adverse events associated with COVID?
We think so, and we're trying that now. So we have a grant from SFI. SFI, as soon as COVID broke, to their credit, SFI is the main government agent, well, one of several government agencies that support science funding. And myself and my colleague Colin Hale have a grant to look at the effect of the gut microbiome on COVID severity. And our hypothesis is exactly as your participant suggested, is that if the gut microbiome is controlling inflammation, people who are more naturally inflamed would be more susceptible and would have more severe disease. And like, we're still doing our analysis, but there are papers already published. There's one in Gut a few weeks ago, which claims that that is the case. But you also have to bear in mind that COVID is a really weird disease, because mutations in innate immune genes like interleukin receptors also appear to be very important. And that's why you see these tragic cases of young healthcare workers in their 30s and 40s who succumb to COVID. So fair play to your participant for detecting that hypothesis, and we're working on it, and hopefully we'll report that in the next couple of months.
Yeah, brilliant question. Very interesting. The next one we have is, can gut microbiome microbes be used in the management of type 1 diabetes, rheumatoid arthritis, or high blood pressure?
Yeah. Type 1 diabetes, I personally don't think so. I've seen one paper from a group in Denmark suggesting that that is the case, but my reading of the literature is that there isn't enough evidence to support that. Rheumatoid arthritis, yes. Similar to the question on inflammation, in collaboration with Professor Mick Malloy, who I previously mentioned, and my colleague, Dr. Ian Jeffrey, we actually did a study on the microbiome in rheumatoid arthritis, and we identified a particular class of bacteria called Prevotella copri, which was elevated. In some microbiome-related diseases, it appears to be losing good bugs, and in others, it appears to be gaining bad bugs, which we prefer to call pathobionts. So rheumatoid arthritis, I'd be cautiously optimistic. High blood pressure, I'd say the jury is still out on that one. I mean, arterial stiffening, that's not really chronic high blood pressure, that's more stroke risk. Some bacteria have been developed to treat blood pressure because they interfere with the angiotensin converting enzyme process. That's a work in progress. And if you want a clear answer, I'd say no, yes, no.
Perfect. Thank you very much. Is there any more questions? Feel free to unmute yourselves or send the remaining questions into the chat.
Hi, Paul, it's Tyke here. Just a question there is, have you read, there's their lecturer there, Luke O'Neill, he actually does go on News Talk now and again. He has a book called, and I apologize, it only came out this year, but the title is Never Mind the Bollocks, Here's the Science. He has you and your paper referenced in it. Have you given it a read?
No, I haven't. No, Luke was a classmate of mine.
Yeah, I think he was a O'Neill as well. Luke talks about like diet in one of his chapters.
Yeah.
And I basically asked the question about the sample size. That was my question there to you,
okay,
Paul.
Yeah.
But it was based on the chapter. The reason being is that like he compared like the keto diet and Weight Watchers and tried to see, you know, which is the most effective diet. The Mediterranean diet also get mentioned. Now, Luke only mentions it briefly, of course, right?
Yeah. And
he just say that like all of these, like, you know, they wouldn't be recommended, but they are at the moment. Like, you are looking at it. Like, so what you're saying anyway, like, you know, with what information you've gathered and others have, that if you, for example, if you wanted to contact Luke, because he even says at the beginning of the book that he's open to any corrections, would you make that challenge to him, or do you think we definitely need more research on the Mediterranean diet?
I definitely would not reach out to Luke because he's a busy guy with lots of media engagements, and I wouldn't like to deprive the News Talk and Irish Independent listeners and viewers of his insights on COVID. I'm not sure exactly what he said, Tig. If he said that the med diet study was underpowered, I mean, the med diet nutritional intervention was designed by the nutrition group in Groningen, and it was published in mainstream nutritional journals, and it was peer reviewed by experts in nutrition, which Luke is not. If I wanted to know about the inflammasome, I'd talk to Luke. I wouldn't talk to him about nutrition. So before we even examined the microbiome, the med diet, which has previously been reported to be beneficial, the med diet had been shown to delay the onset of aging-related health loss. So that's incontrovertible. What we did was to show that the degree of health benefit was directly related to compliance and the change in the microbiome. So I'm quite comfortable with that.
Yeah. Thanks for
no,
that.
No worries, Ty.
Thank you, Ty, for that brilliant question. So if there's no other questions, I'll conclude there. So, on behalf of UCC Science Society and everyone here tonight, I would like to thank you sincerely very much, Paul, for a fantastic and insightful evening. You have certainly succeeded in inspiring us all, and we appreciate you taking the time to share your career in research at Insight.